Bonding as a question 3. So looking at question 3 here, you can see two quite intimidating diagrams here, but they are not to worry. Okay, this is actually your giant ionic structures, or we call it the crystal lattice structure or ionic lattices, whatever the case is. Just take note, these are the structures for ionic compounds. So in part A, they tell you that, okay, ionic compounds, you know, obviously from the ions there, but they say that the melting point actually differs. Magnesium oxide 2852, but sodium chloride 801. So explain why both have high melting point. So they're just asking you, why does ion compounds have high melting point? So in actual fact, high melting boiling point means a lot of energy is needed to overcome the strong ionic bonds, or we can term it as strong electrostatic force of attraction. Okay, strong electrostatic force of attraction. So just take note of these two terms here. When we talk about melting boiling point of ionic compounds, we talk about a lot of energy is needed to overcome strong ionic bonds, or we term it as the strong electrostatic force of attraction. In A part 2, they tell us, or should say they ask us, why is the melting point for magnesium oxide so much higher than that of sodium chloride? So in this case here, this is more like a thinking question. So why is it so? Although they are ions, for them the structures look the same, what is really different is actually the charges. You can see here the charges are different. So we know that the ionic bond of magnesium oxide is stronger, obviously is because of the melting point. Melting point higher, that means the bond should be stronger as more energy is needed to overcome the force of attraction. But why is it so? You can actually say that it's because the charges ion and anions. I to say the cation Mg is 2 plus, but sodium is only a single plus. For oxygen is a 2 minus, but for chlorine it is a minus. So you can see this is 2 minus, 1 minus, so the charge is different. The greater the charge, okay, the greater the charge, the stronger the ion. This is something interesting to note. Next up, 3b. Draw the electronic structure of a magnesium ion and an oxide ion. So in this case here, magnesium ion, oxide ion. You can either do the long way, or you can do the by looking at magnesium having 12, proton number 12, so it has 12 electrons, electronic configuration 282, losing 2 electrons to form 28. So this is your Mg2 plus. Then for oxygen, okay, O816, so 8 electrons. So it is 2.6. What it will do is it will gain 2 electrons to form 28 to form your O2 minus, which is what I've drawn here. So just take note, oxygen, make sure that your 2 electrons, there should be 2 crosses at the outermost shell, as they gain 2 electrons from elsewhere, and this is to indicate where the electrons are from. In this case here, it will be the electrons from your magnesium atom.